Hi folks, we're taking a look at number 19 from page 107, and what we want to do here is find numbers m and b so that this limit here is equal to 1. Now if you watch the video for number 18, you'll see that I showed 4 different ways of solving that problem, okay, with each one with a slightly different perspective. And here I'm going to show you 2 ways. And the reason being that I just really want you to see how, you sometimes just try different things when you're solving a problem like this, which would likely be in the thinking section of the test, and you might end up coming across a full solution. So don't just stare at it, try something. Okay, so my first perspective here is to first notice that the denominator, and we're seeing this as being very common, is the denominator is approaching 0, but the limit exists. So we know that the only way for this limit to exist is if the numerator also approaches 0. Okay, so let's see what kind of information we can get from that. So let's try to figure out what's got to be happening with the numerator if it has to approach 0. So here, let's just write that out. The numerator also has to approach 0 as x approaches 0. Okay, but this here is just a nice function. This is a square root function, and then I'm just subtracting 3. Okay, so this is a continuous function as long as whatever's in the square root is positive. So I can just evaluate this limit by inputting x equals 0. So we're left with root of m times 0 plus b minus 3, and we know this needs to be equal to 0, and so now we've got root b minus 3 equals 0, so root b is equal to 3, and if I square both sides, I got that b must be equal to 9. Okay, so we use this one piece of information, and we were able to determine the value of b. Well, we still have to determine the value of m. Okay, so here we'll use the fact that we know the limit of that function, that it has to be equal to 1. So let's see what happens when I now insert b equals 9. So I go back to the original limit. Okay, so now I have mx plus 9 minus 3 over x. Okay, and well, I need to find a way to reduce this x in the denominator. So again, as soon as you see a square root in that numerator, you should be thinking about rationalizing it. So I'm going to multiply this by root mx plus 9 plus 3. Do the same in the denominator, root mx plus 9 plus 3. And let's see where the algebra takes us. Okay, so this is equal to mx plus 9, and then difference of squares, so that's just minus 9, and the denominator we have x times root mx plus 9 plus 3. And so here, very nicely, these 9's cancel each other out, and now in the numerator all I'm left with is mx, so the x in the numerator reduces with the x in the denominator. Okay, and now I've eliminated the problem in the denominator. So what I'm left with is a function which is continuous, so I can just input x equals 0. So in the numerator I'm left with m, and in the denominator x approaching 0, so mx approaches 0, so I'm left with root 9, which is 3, plus 3 is 6. So I'm left with m over 6. But remember, we were given the value of this limit. We know that m over 6 has to be equal to 1. And so m is equal to 6. Okay, so here are the 2 values we were looking for, and what we used was the fact that in order for a limit to exist, when the denominator is approaching 0, the numerator has to also approach 0. So we see how useful this perspective has been on quite a few problems that we've solved. Okay, but I'm going to take a look at another perspective. Let's say I didn't think of that. Okay, I think maybe a little more about the problems that we've solved that look like these here. Okay, why not just take this limit and start solving it as though it was an indeterminate form. Okay? So here, let's say I just start solving. Limit as x approaches 0 of mx plus b minus 3 over x. Okay, and let's see what I can do. Do some algebra to try to simplify this out. So again, I'm going to multiply numerator and denominator by the conjugate of this numerator, the way I normally would do. So square root of mx plus b plus 3, square root of mx plus b plus 3. Okay, and just see where it takes me. So notice what I'm doing here is I'm just applying whatever methods I would have had to solve this type of limit. Okay, so here, difference of squares, so we have mx plus b, and then here we have minus 9x times this conjugate. Okay, let's simplify as much as we can. So here we're left with mx plus b minus 9 over x times mx plus b plus 3. Okay, so what we need is, in order for us to be able to evaluate this limit, we would need for this x in the denominator to cancel out with the x in the numerator. But what's standing in our way? Well, I have this constant, this b minus 9. Okay, with that b minus 9 there, I can't just easily reduce the x values. So this tells me that b minus 9 would have to be equal to 0. In other words, b equals 9, exactly what we determined earlier. So if b is equal to 9, okay, let's assume it is, we can now cancel out the x's, and we're left with the limit of x approaching 0 of m over square root of mx plus, now we've determined that b has to be equal to 9, plus 3, and now we've eliminated the problem in the denominator. And so I can just evaluate this limit by inputting x equals 0. So we have, as before, this approaches 0, so we have root 9, 3 plus 3 is 6, and here we're given that m over 6, or this limit, has to be equal to 1, so m is equal to 6. Okay? So just by thinking of using the methods we had used previously when we had square roots, we were able to find a solution to this problem without having to think about this numerator needing to approach 0. Okay, so again, two slightly different perspectives to solve the exact same problem. Okay, that's it for this one.